All right, today we're going to talk about some of the biggest environmental fights on the planet, and believe it or not, a surprisingly simple piece of tech that's right there on the front lines. We're diving into Geocylinder and the science of, well, literally engineering the edge of our world.
But let's just start with this question. Really think about it. How do you stop an entire beach from washing out to sea? Or clean up a river that's been contaminated for decades? Where do you even begin? It seems impossibly huge, doesn't it?
Well, to get an answer, we first have to really wrap our heads around the scale of the challenge. We're looking right at that crucial, often fragile line where land meets water.
And we're facing a whole suite of issues here. You've got coastal erosion constantly eating away at our shores, you've got industrial contamination poisoning delicate ecosystems, and of course, rising sea levels are making floods a much bigger threat. And all this means the beaches we love are literally just vanishing into the waves. These aren't just natural cycles anymore. They're massive engineering puzzles that need some seriously innovative solutions.
And that solution, you're not going to believe it. It starts with a tube. Yeah, a giant, high-tech fabric tube that is completely changing the game.
So the basic idea is called a geotextile tube. Just picture a gigantic, incredibly strong sock made from these very specific engineered fabrics. You can pump stuff into it to separate out solids from liquids, or you can fill it up to build solid, stable things like artificial dunes or even breakwaters. It's become a foundational tool in modern environmental engineering.
And the company really leading the charge here is Geocylinder R. It's known as the next-gen geotextile tube for a reason. It takes that core idea and just kicks it up a notch with really advanced materials and cutting-edge Dutch engineering.
Okay, so let's get into the nuts and bolts. How in the world does a big fabric tube clean up a river or rebuild a beach? It all comes down to three things: its ability to filter, to fill, and to fortify.
You know, the magic really starts with the material itself, the geotextile. This is not your average fabric. It's an engineered material with a very precise structure. It's permeable, which just means water can pass through it, but it's also designed to separate, filter, and hold on to whatever you put inside.
So check this out. Here's how the dewatering works. First, you pump a slurry, which is just a fancy word for a mix of water and solids, like contaminated mud, into the geocylinder. Then, that special fabric acts like a giant coffee filter. The water slowly seeps out, but the solids, the coffee grounds, if you will, get trapped and contained inside, getting more and more dense over time.
What's so cool here is that the technology kind of has these two different personalities. On one hand, it's this amazing filter for cleaning things up, separating out contaminants, dewatering industrial sludge, but on the other hand, it's a powerful building block for defense and construction, creating the actual structures that protect our coastlines. But this isn't a one-size-fits-all kind of thing. Let's take a look at how this core idea gets adapted for a whole range of different jobs.
You should really think of it as a whole family of specialized tools. Each one is custom-built for a specific kind of challenge.
For instance, you've got the marine geocylinder. That's the tough guy, with a special coating for harsh marine environments. Then there's the biogeocylinder, which is totally biodegradable, perfect for projects in really sensitive ecosystems. And for emergencies, there's the hydrocylinder, which is designed to be filled with water to create a flood barrier in a hurry.
And that marine version I just mentioned, it has a tensile strength of 300 kilonewtons. Now to be clear, that is an incredible amount of force. It's basically a new benchmark in the industry for just sheer toughness and durability.
And this quote right here shows you what that strength really means in the real world. It's not just some number on a spreadsheet. It's the kind of confidence that lets a company offer lifetime maintenance programs on these absolutely critical structures.
So, let's see how this all plays out in the real world. We're going to look at a few projects where Geocylinder was really put to the test. Our first stop is in the Caribbean. We are in Jamaica, looking at a huge environmental cleanup project.
So the problem here was contaminated sediment in the waterways. So, using that dewatering process we just talked about, engineers pumped all that toxic slurry into the geocylinder tubes. The clean water filtered out, and all the harmful materials were safely trapped and contained. Simple as that. Waterway cleaned. Okay, so from cleanup to construction. Our next stop is Mexico's Yucatan coast. Here, the challenge wasn't pollution, it was disappearance. The beaches here were facing severe erosion. So they flipped the script. Instead of filtering out bad stuff, the goal was to capture something valuable, sand. They used the geocylinder tubes to capture and dewater sand, creating a massive stockpile of dry material that could then be put right back on the beach to rebuild the coastline.
For our last example, we're still in the Caribbean, checking out a resort project that shows some real next-level ingenuity.
So this hotel resort was getting hammered by wave energy. The solution? They built a breakwater using geocylinder tubes to absorb all that impact. But they didn't stop there. They then used that exact same protective structure as the foundation for a brand new pier. I mean, how smart is that? One solution, two problems solved.
And that really brings us to the big takeaway here. This kind of technology gives us an incredible amount of control over our environment. It lets us clean up the mistakes of the past and build defenses against the threats of the future. And that leaves us with one last question to chew on. If we really can design and build our shorelines with this kind of precision, what kind of world do we want to engineer?